Okay, welcome back, guys. We're going to be doing a basic combustion analysis problem. I wanted to cover this for the people who still don't feel comfortable with this because I have a feeling that you'll definitely see something like this on the test, and it's like the basics of a lot of the other problems that you'll be doing, right? So if you can understand this, I feel pretty confident in your ability to solve other things, but you really need to conceptually understand some of the steps. So I'm going to record and I'm going to try to do everything in a different color so that way you feel a little bit more comfortable, and then I'm going to explain things as I go, right? So a couple of things that we need to see first, right? We need to highlight and notice first is that right here, right? This value right here is your total sample mass, right? This is going to contain your C, your H, and your O, all three of them, right? But it's C, H, and O, right? Not CO2, H2O, right? It's C, H, and O. You need to know that those are the three elements combined, right? And so we're also given CO2 and H2O. And so from those, what can we find, right? You've done this before in hydrocarbon analysis, but now we've added oxygen, right? Because it's combustion, and you can't have fire without oxygen, right? So in combustion problems, you'll be able to use CO2 to find your carbon. You'll be able to use H2O to find your H, but then you'll have to do the extra step to find the O, right? So let's start. I will start with the carbon dioxide first. So hopefully I can make this as neat as possible. So carbon dioxide is in red. Grams of CO2, right? I'll put it over an arbitrary 1. That value has no difference, doesn't add anything. I just like to put it there. 44, right? Now this right here, this 44 is CO2, right? It's the molecular mass of CO2. So 2 of the oxygens and 1 carbon. If you add it all up, it adds up to 44. So that's going to give you it's going to give you the moles, right? And then also what we can do here is, since there's 1 carbon in every 1 CO2, right? It's a 1-to-1 ratio. We can find just the moles of carbon, right? If we were to do this, it would give us the moles of CO2, but we don't want that. We just want the moles of carbon, right? So we got to do the 1-to-1 ratio just to prove it, right? So it ends up being something like 0.0044. It's not perfect, but you'll get my point. So hydrogen, right? Let's do that in blue. If you have 1,000 grams of H2O, right, over the arbitrary 1, same concept right here, right? 1 mole over what? It's about 18.02, I believe, right? But the difference here is that you really need to make sure you remember this step, especially for the test, right? It's going to throw everything off if you don't remember this. So here, right, how many hydrogens are there in an H2O, right? It's 2 because there's H2O, right? So in 1, here we go. So you'll end up getting something like 0.0110, right? So now to find the oxygen, which I'll do in green, right? What we can do is, first you need to find the masses of each of these things. So what you'll do is find the mass of carbon, find the mass of hydrogen, and then subtract that from this number right here, right? Because that is the mass of carbon, hydrogen, oxygen. If you subtract the carbon and the hydrogen, what are you left with? You're left with the mass of oxygen. So first, let's try to find this mass. Right. So you'll take the 0.0044 mole of C, and you'll multiply that by the molar mass of carbon, which is this, and you'll get about 0.0533 grams of carbon. Now with hydrogen, you'll take that 0.0110 mole of H, and you'll multiply that by 1.008, and you'll get something like this. And now, so what you want to do to find the oxygen is, you want to take that total sample mass, right? Now this is this thing right here, right? You want to take that, then to find that, you're going to do subtracted by 0.0533 plus 0.0111, and it'll end up equaling about 0.0356 grams of O. So now we have the grams of O, but what we really want is the moles of O. So we'll take that and we'll put it over the arbitrary 1, and 1 mole of O, right? What's the molar mass of O? It's about 16. You do that and you end up getting something like 0.0022 mole O. So now we found the moles of O. We have the moles of H or C, and we have the moles of H. What are we going to do now? Right? Here's that thing that we did with hydrocarbon analysis, right? You're going to take 0.0044. You'll take 0.0110, and you'll take 0.0022. These are all your moles. Now, what's the smallest? It's the moles of O. So you'll divide all of them by this. And for the carbons, you'll end up getting C2. For the hydrogens, you'll get H5. And so this was just 1 to 1, so you'll get 0. So let's fill this out, right? C2, oh, sorry. C2, H5, and then that's just 1. So your final formula ends up being something like C2H5O1. So make sure you guys are finding the moles of C and H, right? Turning that into grams of C and H, subtracting that by the total sample, and then taking that remaining, right, whatever's remaining from that total sample, that's your grams of O, and turning that into moles of O. Now you have all of the moles of C, H, and O, and then you divide by the smallest. Please, please, please don't get confused. There's a lot of steps. So what I would do is, once you found the moles of C and H, I would circle them, right? You don't want to get them confused with this, right? You turn that mole of C into grams of C. You want to make sure you guys are always using the moles of C and the moles of H, not the grams, the moles, right? So please make sure you guys circle those things so you can come back and quickly look at it. Again, if you have any questions, please feel free to email me. My email, you guys will all get my YouTube link in the email. So if you want, you can email me, but happy studying. This is basic combustion. Good luck.